Thank you, ladies and gentlemen, for the opportunity to speak to you tonight. I am Greg Taylor. I grew up in Marion County. I'm a native of Winfield. My dad is from Hamilton, Alabama, and my mother is from Winfield. So I'm an Aggie pirate. Okay. I want to tell all of you we've had some fantastic students from this area at Bevel State, and we appreciate the opportunity of working with your daughters, your sons, your grandsons, granddaughters. We appreciate the opportunity of working with them. A lot of them go to Jasper campus, and also they come to us at Hamilton campus, and we really appreciate the opportunity of working with them. We've got some tremendous students this fall as well. My goal tonight is to give you some basics regarding looking at your ancestry from a DNA perspective. And as I was telling some of you earlier, this is just one tool of many. It's not the only tool. And I think when you're searching for your ancestry, when you're studying that, I think it's really good to just develop a toolbox as you go along. And I think this is one toolbox you can use. Now I'm going to tell you, with every good thing in science, there's a balance. For example, 23andMe, for example, you can check a box, and it'll actually you'll get a report back on a long list of genetic disorders, whether or not you got it. One of them that I was surprised to get on 23andMe was it actually shared that regarding early onset Alzheimer's. And I'm excited to know that I do not have the gene for early onset Alzheimer's. And I didn't even know that was part of the 23andMe package, but it is. Now that doesn't mean I'm never going to get Alzheimer's. That doesn't say that, but I don't have the gene for early onset, and so that's really nice. So tonight we're going to talk about the basics. And I'm going to be very basic with you tonight. My background is this. I'm a graduate of the University of Alabama in Tuscaloosa. I have a biology degree and I minored in chemistry at the university. Went on and got my master's and I got my master's degree in biology and I minored in chemistry as well at the university. And then I got my doctorate in higher education administration, but I minored in biology. It sounds weird for me to say I minored in biology, but I did. After I got my master's, I went and worked in molecular biology research at UEB. I worked there for a number of years, and I was published. You can Google me up. You can go to Google Scholar and put in G.R. Taylor, and put in G.R. Taylor and UEB, and you can read my stuff. Because my research group, we came upon a protein that helped regulate blood pressure that people had been looking for years and years and years. And that led to, about 10 years ago, that led to a whole group of better blood pressure medications. Now, I'm not rich and I'm not famous from that. The university gets all the fame and gets all the fortune. But I'm happy to say that before my grandmother died, she was on medication that my research team had researched. And the moral of that story is, in our daily walks of life, we've got to do our very, very best. Because you never know where something that you do is going to really be the difference with others. You really don't. And I think about that. I think about that going back, and it just gives me chills. Because I really think that God just let us know that one night. I really do, because we really learned that really by mistake. My dad is Jimmy Taylor from Hamilton. He is related to a man by the name of James Taylor, who was a very interesting character. James Taylor was in the Civil War, and he fought for the North. He was a sergeant and fought for the North. As many of you know and have researched, a lot of folks from this area, some folks fought for the North, some folks fought for the South, and a lot of you guys are aware of those backgrounds. My dad's grandmother was Hattie Ophelia Taylor. You knew she was going to be famous because her initials spell hot, H-O-T. Hattie, I'm so proud of Hattie because Hattie was the linchpin of my family back in the 1920s, because in the 1920s a tornado wiped out Hamilton, Alabama during that time, and it wiped out half of my family. And Hattie literally raised an entire family by herself. She was just a linchpin for that community and also a linchpin for my family. It became an honor if you were asked by Hattie to go fishing in Hamilton, Alabama. That was an incredible honor. She just didn't ask anybody to go fishing with her. She had a fishing car and all that, and her fishing trips became legend. Elvis Presley. Well, as it happens, as we're about to see, Mourning Dove is my dad's grandmother 5 back. And it just so happens that Mourning Dove, some of you in this room may be related to Mourning Dove. Mourning Dove was Elvis's, I believe it's third grandmother back is Elvis. So what I'm saying today is my dad is related to Elvis. Mourning Dove, if I was to sequence mitochondrial DNA from Mourning Dove, it would be the same sequence as the mitochondrial DNA that my dad has. Oregon Taylor. Oregon is a direct descendant of Mourning Dove. That's my grandmother. And Garvis Taylor was my granddad, who's passed on from Hamilton. This is my Winfield-based relatives. Again, that will set us up for later. My grandmother is Una Mae Webster Marshall. My granddad is Joe Mac Andrew Marshall, who I'm really proud of. When I retire from Belleville State, I'm going to write a book about Joe Mac Andrew Marshall because he was in 3rd Army under Patton, 47th Armored Field Artillery under General Patton. He was amazed that General Patton was regarded as such a hero. He thought General Patton was absolute nut. He would tell you that. I mean, he thought General Patton was a nut, and he would tell you that. But I need to just write his war stories. He didn't tell me his war stories until I was in a near fatal car accident. And after that car accident, he pulled me aside. He said, "Okay, you've had a near-death experience. You're now in the club. You're going to hear all the stories." And so I wrote down all of his stories, and it's just absolutely fascinating. His story about the Battle of the Bulge is chilling, but that's a forthcoming book. Jimmy Taylor is my dad. Brenda Jo Marshall Taylor is my mother. I'm very proud of my mother. She's now on the school board at Winfield City Schools, and she's serving there now. And my sister is Leah Taylor Pennington, and she was a head majorette at the University of Alabama for 3 years. This is Mourning Dove's. This is not Mourning Dove's tombstone. This is Mourning Dove's daughter's tombstone. And there's been some confusion in the Hamilton area regarding Mourning Dove and her daughter. To understand 23andMe and Ancestry and all these different services, we need to understand, first of all, the flow of information in the cell. What's going on with the flow of information in the cell. We need to learn that first. And the flow of information in the cell, I've made a little drawing for it. Ugly drawing. The way it works, we have DNA in our nucleus. Okay, all of our cells have DNA. And that DNA, fundamental is the molecule of life. You are your DNA. There's subtleties, like if you look around the room, some of you have straight hairlines, some of you have a widow's peak. She has a widow's peak going right here. Some of you have straight hairlines. Straight hairlines is what we call wild type. That's what most people have, if you have a straight hairline. Notice, look around the room, some of you have detached earlobes like I do. My wife has attached earlobes. She says that's more aerodynamic, and she tells me that I'm not aerodynamic, and I'm not as perfect as she is. She says that attached earlobes are more perfect, and I'm flawed because I have detached earlobes. And she reminds me of that every once in a while. She'll go over there and but wild type in humans is detached earlobes. Now, how do we get that? Well, what's going on is we've got DNA in cells that encodes for RNA. RNA is kind of like a molecule of communication. It's kind of like an intermediate between the DNA and then finally our protein. So our flow of information in our cell is DNA, RNA, and then it goes to protein. And these proteins manifest themselves as a detached earlobe, straight hairline, hair color, height, all that's manifested. So here's the flow: DNA, RNA, and then protein. Okay? Now, as we were talking before the meeting tonight, a lot of the things we raise money for, a lot of the diseases we raise money for, what's going on is we're not making, for whatever reason, we're not making the right protein. You know, cystic fibrosis, for example, we're not making the right protein. Various types of arthritis, okay, we're not making the right protein. Blood diseases, we're not making the right protein. Scleroderma, where you have the scaly skin, autoimmune disease, you're not making the right protein. Celiac disease, Crohn's disease, again, not making the right protein. No, I want everybody to notice the color of my hair. I have mouse brown 57 hair by L'Oreal because I'm worth it. Okay? It's getting more gray as time goes on. It's mouse brown 57 plus gray now. Okay? And it's on sale. I saw it's on sale in the paper. There's a coupon for it. Okay? So between the ages of 0 and 6, I had blonde hair. And my mom was just, she was so disappointed because when I turned 7, it turned mouse brown 57. My mom is Irish, and she's redheaded, and she was like, she had this connotation, he's going to be blind. He's going to be this little blonde boy, and it turned mouse brown 57 overnight, And so my point being, as we go through our lives, we use different DNA sequences as we go through our lives. And here's the thing. The thing is this. If we know we've got a bad gene, okay, for example, if you do 23andMe and it comes back, hey, you've got an increased risk of getting heart disease. Well, guess what? That's when you want to make sure you're exercising, make sure you're eating right, not doing, you're not eating at Pizza Hut every night, and you're not a couch potato. 23andMe came back. I've got one of the markers. I don't have a good marker on one. I showed my wife that, and she had read where if you do pomegranate juice, and do green tea, and she's been spiking all my food with oatmeal stuff. My breakfast cereal is rabbit pellets from the co-op. Okay, it is. So the result of that is I had my carotid arteries checked about a month ago. I have the carotid arteries of a teenager. It came back, I'm 10%, both sides. And the way 23andMe said, I shouldn't be that way. All right, here's my ugly drawing of the mitochondria. It's just a circle and a little bean with a squiggle right there. Ugly drawing that's mitochondria. The mitochondria There's a lot of theories on the mitochondria. Here's the thing. The mitochondria is about the size of a bacterium. Okay, it's about the size of a bacterium. And there's a lot of biologists who believe, now not all, but a lot of them believe that at one time the mitochondria was actually a free-living organism to itself. And there's a lot of evidence for it because the mitochondria has its own DNA sequence. Okay? Now here's what the mitochondria does. The mitochondria allows your cells to take in oxygen and burn glucose. Okay, that's what your cells do. Your cells take in oxygen, they take glucose, and they burn it. Okay? And all the food you eat breaks down to form glucose. If you're eating fat, it's going to break down to form glucose. If you eat sugar, you're going to break it down to glucose. So anything you eat is, fat, carbohydrates, proteins, your body's going to break it down, your cells are going to break it down to glucose. What the mitochondria do, the mitochondria take oxygen from that, and they're going to help your cells burn that glucose. Okay? Where respiration takes place in your cells. Okay? And you'll notice that some parts of our body have more mitochondria in them than others. For example, your muscles, you've got a lot of mitochondria in your muscles. A lot of them. Because your muscles have to burn a lot of glucose. Okay? And some of you may be on if you're on a statin for your some of you, and I'm on a statin too. If you're on a statin for your cholesterol level, oftentimes your doctor will tell you to get on coenzyme Q10 with it. You may have heard that. Take coenzyme Q10, especially if you're on a statin. Well, the reason being is coenzyme Q10 is a very important enzyme that the mitochondria uses. And it's used in the breaking down of the burning of glucose. And what statins do is statins reduce that. Okay, statins reduce that. So you need more coenzyme Q10 to overcome that statin. And that's why a lot of times that's why you get cramps. Like if you don't do coenzyme Q10, you'll do the statin, it'll give you cramps. That's why, because it's depleting your coenzyme Q10 stores. So that's what the mitochondria does. Now here's the thing. The mitochondria has its own DNA. And here's what's important for y'all. It's got its own DNA. And it doesn't change much over time. I could exhume, I'm not going to do it, but I could exhume my grandmother 20 back. My mitochondrial DNA sequence is going to be the same as hers. And here's the thing. You get your initial, here's the other thing that you guys need to write down and be aware of. You get your initial mitochondria from your mom. The egg you get from your mother has your initial mitochondria in it. So right now, you think about it, you've got in every cell of your body, you've got mitochondria from your mother. I do. Little tiny leprechaun Irish woman, I've got that in every cell of my body. I've got her mitochondrial DNA sequence. I've got it. My dad, whose mom is a descendant of mourning dove, my dad has mitochondrial DNA sequence that's going to be the same as mourning dove. So if you guys ever want to get some mitochondrial DNA sequence of mourning dove, just, hey, give me a call. I'll get you a blood sample. And I love the stories from speaking of mourning dove, I love her stories. She would tell her family, they'd want to call her Sarah. She said, my name is not Sarah. My name, I am mourning dove. A-T-C and G. Those are the 4 letters of DNA. Here's how you can remember them. You're all sitting there saying, oh, it's going to be A, T, C, G. Don't do that. It's Andy Taylor, Cousin Goober. You got it? Oh, you got it now? That just fixes everything. Andy Taylor, cousin Goober. You know, Andy pairs with Taylor, cousin pairs with Goober, right? I came upon that. I was working at UB one night, late one night. I was painfully doing, well, T pairs with A, C pairs with D. I was just writing it all out there. And then it hit me. You know, I really wish I was home watching Andy Griffith, you know? And then it hit me. A, T, C, G. Andy Taylor, cousin Goober. RNA is almost the same thing. It's cousin Goober goes to University of Alaska. UACD. You Alabama fans, well, you need to be saying University of Alabama. You Auburn people are going to say, well, it's Auburn University, right? But it's RNA. The 4 letters of RNA are University of Alaska and cousin Goober. Okay, so that's a DNA sentence. And so for the next 90 years, we're going to be figuring out what that sentence means. Because back in 1999, if you remember 1999, that's when we sequenced DNA from the entire DNA sequence from a human. We did it back in 1999. And to be honest with you, ladies and gentlemen, that was more significant than landing on the moon. Also, another significant thing that came out in 1999 is Bill Clinton had a law passed. When that happened, everybody panicked. So, oh my goodness, we're going to start cloning humans. Remember that? Oh, we're going to clone. We can't clone humans. So Bill Clinton had a law passed, through Congress, and it basically said you cannot clone humans. However, you can, thank goodness, you can clone plants. That kept my grandmother out of jail. Nobody cloned plants more than my grandmother. You call that, here in Winston County, we call cloning plants, we call it root. Right? She was starting to sweat about that a little bit. I had a conversation with her. I said, you know, cloning stuff's about to be illegal. She said, ooh, yeah, I don't want that to happen. Okay, so that's our. So back in '99, we got the sentence of a person, and so now what we're trying to do is we're trying to figure out what all those letters mean. And here's the good part. We're really getting down the road here. We're learning. We're finding out what does what, and we're doing it quickly. Back in '99, I remember they said it was going to take about 90 years for us to figure all that out. I don't think it's going to take 90 years. I think by the year about 2030 or 2040, we're literally going to know what everything in our sequence does. Because we already know a lot. I mean, I was amazed to see my 23andMe report, and it basically came back and said, hey, you don't have early onset Alzheimer's. Hey, part of that is taking care of your mitochondria. That's going to help. You want your mitochondria to be healthy. And the healthier they are, the better you're going to do. Okay, now, when you do 23andMe, it's going to come back and it's going to tell you what it's going to come back and it's going to give you all these reports. And Ancestry.com is going to come out with all these reports. And it's going to tell you what your haplogroup is. And one of the most important things I need to share with you guys tonight is the issue of haplogroups. You need to think of a haplogroup as your clan. Okay, you need to think about a haplogroup as your clan. And what you're going to find is haplogroups, this is a set of genes. This is a set of genes that you have in common with a specific, you can call it clan. Okay? And I want to put that on your radar because what you can start doing is once you discover what haplogroups you're in, it's kind of like saying, when you get a haplogroup, it's kind of like saying, okay, genetically you are, I can tell genetically that you are a Crimson Tider, or I can tell genetically you're going to be from the Auburn Nation. It's like, we kind of have these clans going in the state already, don't we? I mean, I tell people I've married an Auburn woman, and it's like, you've defected to the other side. How did my haplogroups get here? And you're also going to find that you are going to have people in haplogroups that are here in Winston County. And it's really neat. It can really help you if you're really looking at migration patterns, that kind of thing. It can really be a tremendous help to you. So I want to put that's one of the most important things I want to share with you tonight. Pay close attention to your haplogroups, and you can do, once you find that, you can do some really great research on haplogroups going forward. We don't know how this is going to be used.